All right, buckle up, everybody. We're diving deep into FoundationDB today. You know, that open source distributed database that's been making some serious noise. It's powering some pretty big names, too, like Apple and Snowflake. So we have to find out what makes it tick, what makes it so special.
Yeah, it's not just hype. FoundationDB is really tackling the big challenges of modern data storage head on. We're talking massive scalability,
Yeah.
rock solid reliability, and the kind of developer friendliness that everyone wants.
Yeah, and one of the things that really grabbed my attention is how it blends the best of both worlds. It has the flexibility and scalability of NoSQL systems, but it also has those strong transactional guarantees of traditional databases. And that is a tough act to balance.
Oh yeah, it really is. And the need for that blend is only growing by the day. As cloud services keep expanding, they need databases that can handle these massive amounts of data, constantly changing demands. But they can't give up data integrity either. Businesses rely on that. That's where FoundationDB comes in, bringing those ACD properties into the NoSQL world.
Okay, hold on. Let's unpack that little. ACD properties. I know they're important, but remind me why.
Imagine booking a flight online. You hit confirm. Boom, your seat is reserved, payment goes through, itinerary is updated. That's ACD in action. So atomicity, that ensures that the whole process, the whole booking process, is treated as a single unit. So it either completes fully or it doesn't happen at all.
Makes sense.
Then there's consistency. That ensures that your booking data matches what the airline has in their records.
Gotcha.
Then we have isolation. So that means your booking isn't interfering with someone else trying to book the same seat at the same time.
Right, right. No double bookings.
Exactly.
Yeah.
And then lastly, there's durability. Well, that just means your booking isn't going to disappear into thin air, even if there's a system hiccup.
Gotcha. So FoundationDB, even in this massive distributed system, with data spread across maybe hundreds of servers, it can still provide the same level of rock-solid reliability as a traditional database.
Exactly right. And they do this through some really clever architectural choices. One of the keys is their unbundled approach.
Unbundled, so it's not your typical monolithic database.
Not at all. They separate the core functions of the database into these distinct components. You have the control plane, the transaction management system, and the storage layer.
Okay, I'm curious. Why break things up like that? It seems like it would make things more complex, not less.
Well, think of it like a really well-organized factory. Each department has a specific role. They work together seamlessly to produce that final product. And in FoundationDB, this unbundling, it allows each component to scale independently. You get immense flexibility and efficiency. Need more processing power for reads. Just add more servers to the storage layer. Seeing a spike in transactions. Beef up the transaction management system.
So it's like a database that can adapt and grow with your needs, right? It focuses resources where they're needed most.
Precisely. Now, let's look closer at the data plane. That's where all the data handling magic happens. It's made up of three key players: the transaction system, the log system, and the storage system.
Okay, three systems working together. I'm picturing a relay race here.
I like that. So the transaction system is like the first runner, receiving your requests to read or write data, checks for conflicts, makes sure everything is in order. Then it passes the baton to the log system.
So the log system, that's like the record keeper, making sure every step is documented.
Exactly. It records every transaction, ensures durability, just in case of failures. And finally, we have the storage system, our anchor leg, taking that data and storing it safely, ready to be retrieved when needed.
Okay, this relay race view, it's really helpful. But how does FoundationDB handle all these concurrent transactions flying around the system? How do they keep things from getting jumbled up?
That's where it gets even more interesting. They use a combination of optimistic concurrency control, or OCC, and multi-version concurrency control, MVCC. Don't worry about the acronyms for now. The idea is actually pretty elegant.
All right, I'm ready. Demystify it for me. What's going on behind the scenes?
Okay, so think of OCC like a system that trusts everyone is going to follow the rules. Each transaction proceeds, optimistically, assuming there won't be any conflicts with others. Now, if a conflict is detected, like two people trying to edit the same data at the same time, then one transaction is going to have to restart.
So it's efficient as long as everyone plays nice.
Exactly. But what if you do have conflicting changes? That's where MVCC comes in. It makes sure that each transaction sees a consistent snapshot of the database, even if other changes are happening at the same time. It's like taking a picture of the race at different points in time. Each transaction gets its own snapshot, so they don't interfere with each other.
Okay, I see how these two work together. OCC keeps things running smoothly most of the time, and MVCC steps in when things get a bit messy. But this brings up an interesting question. What if a server crashes or something totally unexpected happens? We'll have to dig into that more next time.
Absolutely. That's where FoundationDB's approach to logging, replication, and recovery really stands out. Stay tuned as we uncover the secrets of how it bounces back from those failures.
Welcome back. So we've been exploring how FoundationDB handles data consistency and concurrency. But let's face it, in the real world, things don't always go as planned. Servers crash, networks have hiccups, even entire data centers can have issues. So how does FoundationDB handle these inevitable bumps in the road?
Right. Well, that's where its approach to logging, replication, and recovery comes in.
Hmm.
Remember that log system we talked about?
Yeah.
The meticulous record keeper? That's the key to FoundationDB's resilience.
Right, makes sense. Because even with clever concurrency control, if the data is lost, it's game over.
Exactly. FoundationDB goes to great lengths to ensure that every single committed write is durable, meaning it won't be lost, even if there are failures.
Okay, walk me through how it works.
Okay, well,
Hmm.
imagine having multiple backups of your most important documents, stored in different locations, right? That's what FoundationDB does with its log servers. Each write operation is logged to multiple log servers, and they're spread across different machines, potentially even different data centers.
So even if one log server goes down, the data is still safe on the others. It's like a safety net.
Exactly. And this redundancy, it extends to the data itself. FoundationDB replicates data across multiple storage servers. So if a whole server fails, you don't lose any data.
That's impressive, but what really makes a database stand out in terms of reliability is how quickly it can recover from a failure. I've seen systems take hours, even days, to get back online.
Yeah, and that's where FoundationDB's recovery process is really impressive. It's super fast and efficient. And that's because of this clever trick. Instead of replaying the entire log, which can take a long time, they focus on finding the end of the log.
That sounds a little counterintuitive. Wouldn't you need the whole log to reconstruct the database's state?
Not necessarily. Remember the storage servers. They're constantly pulling and applying logs in the background. So when a failure occurs, they don't have to start from scratch. They just need to figure out where they left off.
Mm.
What was the last transaction fully processed before the crash?
So it's less about reconstructing the past and more about establishing a solid foundation for the present. Clever. But what about geo-replication? How does FoundationDB handle keeping data consistent and available across different geographic regions?
Yeah, that's critical for any globally distributed system. Imagine you have a primary data center in the US and a secondary one in Europe. You want to make sure that if the primary goes down, the secondary can take over seamlessly without any data loss
Hmm.
and with minimal performance impact.
Right. But usually you have to choose between speed and consistency, right? You either sacrifice performance for strong consistency, or you risk data discrepancies for the sake of speed.
Yeah, traditionally that's been the trade-off. But FoundationDB has this innovative solution. It balances these competing needs. It uses a combination of synchronous and asynchronous replication, along with these specialized components called satellites.
Satellites. Interesting. Tell me more.
So think of satellites as like mini data centers within a region. They act as local hubs for log replicas. So when a write happens, it's first committed synchronously to the primary data center and its satellites.
So you get that immediate confirmation of durability without waiting for data to travel across continents.
Exactly. Then, updates are replicated asynchronously to the secondary region. This ensures that data is eventually consistent across all locations.
Okay, I see how that balances performance and consistency, but what if the primary data center goes completely offline? How does the secondary region know where to start?
That's where the log routers step in. They efficiently transfer log entries between regions. When the secondary region takes over, it can quickly fetch any missing logs from those satellites. So there's a seamless transition and minimal data loss.
So it's like having a dedicated courier service for those crucial log entries, speeding up the recovery process. Okay, this all sounds incredibly robust. But even with all these mechanisms in place, how can you really be confident that a system as complex as FoundationDB will hold up under pressure? I mean, there are so many potential points of failure in a distributed system.
You're absolutely right, and this is where it gets really mind-blowing. They built a simulator?
Wait, like a flight simulator?
Not quite, but the idea is similar.
Right?
They built this deterministic simulator that can run the entire FoundationDB system in a virtual environment.
Hold on, are we talking about a video game version of a database? I'm having trouble picturing this.
It's not a game, but the analogy is closer than you might think. This simulator lets them simulate all sorts of failures, network outages, disk crashes, even entire data center failures. And because it's deterministic, meaning the same inputs always produce the same outputs, They can precisely reproduce any bugs they encounter.
So it's like having a time machine for debugging. They can rewind and replay any failure scenario until they find the root cause.
Precisely. This level of testing is incredibly thorough. It gives them huge confidence in the reliability and correctness of FoundationDB.
This simulator sounds like a game changer. It's like taking all those what-if disaster scenarios, those that keep you up at night, and actually testing them in a safe environment. I'm impressed.
It's a remarkable achievement for sure. It speaks to their dedication to building a truly robust and reliable system.
Well, we've covered a lot of ground here, from architectural choices to these ingenious replication strategies, and even a mind-blowing simulator. I'm eager to dig into some real-world performance results, see how all of this translates into actual numbers.
Absolutely. Stay with us as we delve into the performance metrics. We'll see just how well FoundationDB handles the demands of modern applications.
All right, welcome back, everyone. So we've been on this incredible journey with FoundationDB. We've seen its architecture, how it handles concurrency and failures, even that amazing simulator for testing all those disaster scenarios. But at the end of the day, the question is, does it deliver? How does all of this translate into real-world performance?
Right. That's the ultimate test. And the good news is FoundationDB doesn't just sound good in theory. It actually performs incredibly well under pressure.
Okay, give me the numbers.
All right, so the FoundationDB team has published some pretty impressive performance metrics based on both production deployments and rigorous testing. For starters, they've seen production clusters handling hundreds of thousands of operations per second, both reads and writes.
Wow.
And what's remarkable is they achieve this while maintaining really low latency.
Low latency, that's what everyone wants to hear. What kind of numbers are we talking about?
Think single-digit milliseconds for reads, often just a few milliseconds to fetch the data you need.
That's fast. What about writes, though? Those usually involve more overhead, especially in a distributed system.
You're right, writes are more complex. But even write latencies are surprisingly low in FoundationDB. They've reported average write latencies of around 20 milliseconds in their production environments.
Okay, so even under heavy load, FoundationDB can keep up with the demands of modern applications. But how about scalability? Can it handle those ever-increasing data volumes, those user demands, everything we see in today's cloud-based world?
Yeah, and that's where FoundationDB truly shines. Their scalability tests have shown it can, gracefully handle increasing loads. You just add more resources to the system as you need them. They've demonstrated near linear scalability
Right.
for both reads and writes. So you double the number of servers, you basically double the throughput.
So it lives up to that promise of elastic scalability. That's crucial for cloud-native applications. You can scale up or down as needed, no major re-architecting, no performance hits.
Exactly. And remember that fast recovery process we talked about?
Yeah.
Well, their measurements show that. The typical recovery times are often under 5 seconds, even for large multi-node clusters.
5 seconds, that's amazing. Most databases would be struggling to get back online after a failure like that. It would take them minutes, maybe even hours to replay logs and rebuild state.
It really shows how well their architecture works. That focus on minimizing the recovery work really pays off.
Definitely. But beyond the performance numbers, I think one of the most valuable things we can learn from FoundationDB is the importance of rigorous testing, especially for these complex distributed systems.
You're talking about that simulator again, right?
Yeah.
It's been absolutely crucial for them to be able to move quickly and confidently. They know they can thoroughly test any changes or new features before they go live. It's not just about finding bugs. It's about building confidence in the system's, resilience, its correctness.
I can't overstate how important that is. Imagine the peace of mind you get as a developer, right? Knowing you can simulate basically any failure scenario and then track down those bugs really precisely.
It's a game changer for sure. And I think it's a lesson that more teams building these kinds of systems could learn from. That investment in testing, it pays off in the long run. Less risk, faster development, and ultimately a much more reliable system.
Well, I think we've reached the end of our deep dive into FoundationDB, and I have to say, I'm really impressed. It's a fascinating combination of, innovative design, rigorous engineering, and a real commitment to performance and reliability.
I agree. It's a great example of how thinking differently about database architecture and really embracing thorough testing can lead to some groundbreaking results.
Yeah, who knows, maybe some of these ideas will inspire the next generation of data storage solutions. But for now, we hope you've enjoyed this deep dive with us. Until next time, keep exploring, keep learning, and keep diving deep.